I've been invited to give lots of talks on this topic over the years. About half the time it's a technical audience, or ranging everywhere from Cambridge University to Princeton University to the Wall Street Telecommunications Association. I mean, a wide range all the way down to New Age type groups. Well, speaking to a New Age group is preaching to the converted, and it feels good, but it doesn't feel like much is happening as a result. But speaking to an audience at Princeton or Bell Labs or Cambridge is much more interesting for two reasons. First of all, the audiences are as packed, standing room only, as the public forums. And so at the end of the talk, people often ask, especially scientists, why are you interested in this? With the implication that I must be a psychic in the closet or something, or I have some religious context. And my response is always the same. The response is, why is this room filled to the rafters? Why is everyone here? All of you guys are scientists or technical people. Why did you come? And the reason they come is the same reason that everyone else comes, because there's the kind of a sense that if this is true, it's very, very interesting and maybe important. And so the human part of scientists is there. When I finish, of course, I give a very different talk to scientists than I do to the general public. It's a talk that basically is an hour's worth of data, because that's all that scientists really pay attention to. At the end of an hour's worth of data, there's usually a predictable response, which is stunned silence. And the stunned silence comes about because most scientists are simply unaware of the fact that there is a lot of science underneath this, that I don't need to do a lot of hand-waving and tap dancing to make a case. I simply present years and years of replicable data. And for scientists, it's shocking because they didn't read about this in school.
You must love that silence. You must love the silent.
Well, it's predictable at this point, so I would be surprised if there was anything other than that. There's another response, which is it becomes very easy to identify people who feel significantly threatened as a result of the data, because the data it is compounding, and it continues to compound, and eventually the data will overwhelm opinion. When that happens, I don't know. It could be next year, it could be 10 years from now. But nevertheless, the data is reasonably consistent over time, and because of that, we now have a scientific basis for saying that this is not going away. And we're seeing about the same effect over long periods of time. Somebody's going to be clever enough and figure out a theory that would accommodate this. And actually, if you've been paying attention mainly to advancements in quantum mechanics, theories and applications, I believe that there's a convergence occurring. It's most clearly seen in physics, but it's also seen in chaos theory and the leading edge of developmental biology and a few other disciplines, all suggesting that the way that we have approached science in the past has been to take a completely holistic world, the universe. Of course, the name means. I guess so. I mean, all of it has been on the air. Does that make it public domain?
Yeah.
Yeah.
I mean, you were saying about a convergence.
One of the ways of looking at what's happening in science is when science first began, and it was before science, a philosopher and a scientist and a theologian were all the same, an alchemist. It was all the same thing because the world was seen as an organic whole. When science started, one of the results of that was splitting the world up. And it turned out to be a very powerful tool, because if you concentrate only on studying this piece of plastic, you'll learn a whole lot about it. But by virtue of doing that, you start cutting down the world and you fracture it. And now what we're left with after 300 years of doing this is extremely high knowledge, very deep knowledge about lots of little fractured pieces. And there's an illusion that we're beginning to understand the world. At the end of all of these deep mine shafts of knowledge, we understand it at that level. But it's often forgotten that most of the rest of the world has been completely overlooked. And just to give you one example of that, the discipline of biology started, and it went along a certain way, and the discipline of chemistry started, went along a certain way, and somebody at some point realized, they're not really different, so biochemistry was formed. And then neurology and anatomy was formed, and cognitive science, and somebody came along and said, they're not really different either, so neuroscience was formed. Well, what parapsychology is is an attempt at forming physics and psychology. Now, physics and psychology are not as close as biology and chemistry, but they're also they're not really far apart. Nothing is far apart. Parapsychology is trying to push them together. And when we do push them together, we find that there's an interesting scientific basis for some weird things, like telepathy, connections at a distance. And there's a strange thing in physics, too, connections at a distance, which we call quantum non-locality. Well, a physicist who only knows about physics, or a psychologist who only knows about psychology, will say that there's no connection between quantum non-locality and telepathy. Because, I mean, how could that possibly be? And my response is, the connection is through our experience. We know that the physical world is non-local. We have experiences, subjectively, that says it's non-local as well. So what's the difference between the two? The difference, the thing that's lacking is the connection between. And it's not surprising that we don't have good connections between physics and psychology, because in order to pass through that realm, you also have to understand the nature of conscious awareness. And as Nick Herbert, the physicist, once said, what we know mainly about consciousness is that it has more to do with the head than it does with the foot. That's about the level of knowledge that we have. Another statement I like is, we know more about the moons of Neptune than we do about the human mind. And that is almost literally true, because we don't have probes that we could send into the mind yet, other than people's reports. And we're at the beginning of something very interesting, and where it leads we don't really know, but I suspect, and my colleagues suspect as well, that the revolution that will occur as a result of understanding the mind more will be similar to the revolution that changed Newtonian mechanics into quantum mechanics and relativity. So you're coming from a world which seems like common sense, and it's like balls and sticks, and that's how physics works, into a world where suddenly space is curved and the speed of light is limited, and you can go backwards and forwards in time, and all kinds of really bizarre things. Who would have predicted that? Newton would not have predicted it. So now we're at the threshold of the next century, and the threshold, I believe, of an understanding, a new type of understanding, which will do something like, and this is, again, an analogy, Einstein showed that matter and energy were essentially the same thing, which is not intuitive at all until after the fact. I think we're beginning to learn that matter, energy, and aspects of the mind are also the same. So we'll have a new form of E equals mc squared, where the m part might be the mind. And of course, where does that lead? I don't know. It's almost unimaginable where it would lead, but the data certainly suggests that. Even historically, it suggests that we're on the cusp of a major change. You know, when you're involved in scientific controversies, you can't help but get interested in pioneers who came before you. And what you find is that the history of inventions, not science, but just inventions, and new scientific advances were always shrouded in enormous controversy, and the people who were proposing the new ideas were called frauds and incompetent and hounded out of science, and all kinds of horrible stories like that. It's not well known, for example, that Einstein, when he first proposed quantum mechanics, even though a few of his colleagues knew that this was something interesting, the rest of science went berserk. And besides ignoring him, said that this was ridiculous, this was absurd, these theories couldn't possibly be true. Something like that is going to happen in this realm as well. And in fact, we already see that it's happening. The data is compounding, it's presenting a crisis for science. And somebody's going to come along, probably a very young person, who doesn't have to unlearn all of the previous stuff, who will see it in a new way that we haven't seen before. And that's one of the reasons why I am trying to reach out more to the media now, because young people are uniformly interested in this topic. If they're taught the nature of the data and the controversies and all the rest of it, one of those kids is going to come up with an idea that's going to revolutionize the world.
A lot of times I think,